How tall was the giant Goliath anyway? If all men of that time, some 2,200 plus years ago, had an average height of, say, 3.5 cubits, then someone 4 cubits in a span would be the stuff of legend. In modern times, certainly not so. 4 cubits in a span is just 6'9". There's lots of evidence that people's average height has increased. We can see it in the museums of medieval armor, reckoning the size of the men that it was made to fit. Can we find a statistical test to determine if there really is a significant difference in people's heights across time? And you're not surprised to hear that we can. Often, we will want to be able to compare two different groups on some basis, perhaps height, perhaps SAT scores, or perhaps the rates of return and risk. These examples are all for continuous random variables, feet and inches, aptitude scores, dollars. There are also cases where we want to know if the proportion of some variable, a binary random variable, is different across groups. Is it true that women prefer Dr. Pepper to a greater extent than men? That college sophomores have a slump in their grades, meaning that there is a higher percentage of sophomores with flunking grades than, say, freshmen? Or that the proportion of car accidents attributed to drinking and driving is less than that attributed to texting and driving? These are binary random variables, and thus the parameter we use to make these tests is p, from the binomial probability density function. We will develop test statistics that are capable of answering these questions. By the end of this unit, you should be able to develop tests of hypotheses for both differences in population means and for differences in population proportions. The foundation for these tests has already been laid. There will be no change in the process. The null and alternative hypothesis set up the same way as before, with the status quo in the null and the contender in the alternative. The alpha error will still represent the probability of rejecting a good null, and we will be setting the alpha error to determine the level of confidence we wish to maintain. Importantly, the decision rule will also remain the same. Again, we will ask, how unusual is the difference between the sample parameters of these two groups? How many standard deviations away from each other are they? If they are, say, 2 standard deviations away, we deem this to be unusual and believe that they are the same. Could they be? Sure, but with very little probability, and very importantly, a probability we know. And what about the sampling distribution? As always, we need to know this, to know what distribution to use for our test statistic. Earlier, we got our answer from the central limit theorem. From this theorem, we found that for both the means and for proportions, the sampling distribution was the normal distribution. Spoiler alert, don't be too surprised when we find out that the same thing for the differences in means and differences in proportions. And we will get our answer from the same source. In this unit, you will develop the test statistics and the null and alternative hypotheses for testing differences in two means and differences in two proportions. We will be able to identify situations where these tests are appropriate, and will be able to conduct these tests. The textbook we are using has 2 interesting additional supplemental resources covering tests for differences in means that will not be covered in the course or on videos. The first is really not that interesting. It assumes that we know the standard deviations of the two populations, and that will never happen. The second section does provide an interesting statistical test for differences in means if you happen to have the luxury of matched pair samples. Much is often made about differences. Differences in most everything. Often this is done as a marketing strategy. Our product is better than theirs, is different than theirs, buy ours. Often it seems differences are alleged to exploit some potential gain. Whether these alleged differences are real or contrived for the purpose of financial gain, the product of malicious intent, or the result of bias and ignorance, we will have the tools to determine with alpha probability the reality of their existence.